The chart below shows an expression evaluated for 4 different values of x. The first column has x values 1, 2, 6, and 7, and in the second column, we're plugging those values into this expression, x squared plus x plus 5. The sentence below, Josiah concluded that for all positive values of x, x squared plus x plus 5 produces a prime number. Which value of x serves as a counterexample to prove Josiah's conclusion false? All right, first of all, a prime number is a number whose only factors are 1 and itself. For example, if we have the number 8, we can divide it by 1, 2, 4, and 8 cleanly. However, if we have the number 7, we can only divide it by 1 and 7 cleanly. So in this case, we call 7 a prime number, and 8 would be a composite number. So our first sentence over here says that Josiah concluded that for all positive values of x, our expression here produces a prime number. So looking at the table, he put in positive values for x and plugged it into this expression, and he got prime numbers. For example, 7's a prime number. We've shown that 1 and 7 are the only factors. Similarly, 11's a prime number. 1 and 11 are the only factors. There's no other number between 1 and 11 that you could divide into 11. And we see the same for 47 and 61. So Josiah keeps putting in x values into our expression, and he keeps getting prime numbers. So he concluded that any positive x value produces a prime number. And so our question is, which value of x below serves as a counterexample to prove that Josiah's conclusion is false? So a counterexample is an example that disproves something. If Josiah is claiming that every positive x value produces a prime number in the second column, if we want to prove him wrong, we just need to find one x value that does not produce a prime number. So essentially, we just need to check these 4 values for x and then see what our second column is. If we find an answer that is not prime, then that is a counterexample. So for example, if our answer in our second column is 16, well, 16 is not a prime number. It's composite because it has multiple factors. So that would prove Josiah wrong. So let's go ahead and check 5 and see what it'll be. If we plug in x equals 5 into our expression, that'll be 5 squared plus 5 plus 5. 5 squared is 25. And 25 plus 5 gives us 30, and another 5 gives us 35. So in our second column, 5 produces 35. So is that a prime number? Are the only factors 1 and 35? Well, no. We can divide 35 by 5 and 7. So 35 is not prime. And looking at our first sentence, Josiah said that for all positive values of x, our expression produces a prime number. So we showed that for 5, we don't get a prime number. So 5 would be a counterexample. So we don't need to check the other options. Our answer would be A. The quantity 4x squared minus 2x plus 8 minus the quantity x squared plus 3x minus 2 equals what? So we're subtracting 2 polynomials. So we have 4x squared minus 2x plus 8. And we've seen that subtracting a number is the same as adding a negative. So we'll have plus negative 1 times the quantity x squared plus 3x minus 2 And now our next step will be to distribute that -1. We'll keep our first polynomial the same. Then we'll have -1 times x squared plus -1 times 3x minus -1 times 2. Again, leaving the first polynomial the same. -1 times x squared gives us -x squared. -1 times 3x gives us -3x. And -1 times 2 gives us -2. We have plus -x squared, so we can write that as minus x squared, plus -3x, which is minus 3x, and then we have minus -2. Minus a negative number turns it into a positive, so we have plus 2. Now we just need to get our similar pieces together. We have some x squareds, some x's, and some constants. So we'll rewrite this as 4x squared minus x squared. So we've grouped our x squareds together. Then minus 2x minus 3x. That groups our x's. And then we have plus 8 plus 2. Now we have 4x squared minus 1x squared, which gives us 3x squared. Then we have negative 2x minus 3x, which gives us negative 5x. And then 8 plus 2 gives us 10. So this is our answer, 3x squared minus 5x plus 10. And looking at our answer choices, that would be option D. The sum of two binomials is 5x squared minus 6x if one of the binomials is 3x squared minus 2x. What is the other binomial? So the word binomial just means two terms. The bi part of it means two. You'll also see it in the word bicycle. So a bicycle has two wheels. That's what that bi means, two. And in this case, a binomial has two terms, two pieces to it. So the question's saying that this binomial here plus another one equals this guy. So let's try to write down that thinking. So 3x squared minus 2x plus some other binomial equals 5x squared minus 6x. So this box is our unknown. We need to figure out what that is. So we can think of it like a variable. We just need to get it by itself. So we can start off by subtracting 3x squared from both sides. That gives us negative 2x plus our unknown equals, and 5x squared minus 3x squared gives us 2x squared. And we have minus 6x. We've almost got our unknown by itself. We just need to add 2x to both sides. On the left side, we're left with our unknown. And on the right side, 2x squared. And minus 6 plus 2 is minus 4. So our unknown binomial is 2x squared minus 4x. And looking at our answer choices, that would be option A. Which of the following expressions is equal to x plus 2 plus x minus 2 times 2x plus 1? So we're multiplying two binomials, so we'll need the FOIL method. So we have x plus 2 plus, and for the FOIL method, we need to have two numbers added times two numbers added. So we're going to rewrite x minus 2 as x plus negative 2. And our second one is okay. It's 2x plus 1. We'll leave our x plus 2 the same. And now we can use the FOIL method. So we start off by multiplying our first pieces. That'll be x times 2x. Then we multiply our outer pieces. that's 1 times x. Our inner pieces, that's negative 2 times 2x. And then our last pieces, that's negative 2 times 1. X times 2x gives us 2x squared. 1 times x gives us x. Negative 2 times 2x gives us negative 4x. And negative 2 times 1 gives us negative 2. Simplifying this, we have x plus 2 plus 2x squared plus x and plus negative 4x, which is the same as minus 4x, and plus negative 2, which is the same as minus 2. So we'll need to group our similar pieces together. We have an x squared piece. We have some x's. And we have some constants. X plus x gives us 2x, minus 4 gives us negative 2x, and 2 minus 2 gives us 0. So this is our final answer, 2x squared minus 2x. And looking at our answer choices, that is option A. A volleyball court is shaped like a rectangle. It has a width of x meters and a length of 2x meters. Which expression gives the area of the court in square meters? So our volleyball court is shaped like a rectangle. The width is x meters, and the length is 2x meters. And we need to give the area of the court. So area of a rectangle is length times width. So in our case, our length is 2x meters, and our width is x meters. So 2x is the same as 2 times x. So we have 2 times x times x. X times x gives us x squared. So our answer is 2x squared. And looking at our answer choices, that would be option B. What is the perimeter of the figure shown below, which is not drawn to scale? So the word perimeter, that's a word from geometry. It means the distance around something. And when they're saying not drawn to scale, that means it's not a perfect picture. For example, we have this area that's 2 units long, and this other section that's 8 units long. If this were drawn to scale, that orange line would have to be 4 times as long as the green line. So we want to focus on the numbers and not so much on how this picture looks. So the question's asking, what is the distance around this figure? So essentially, we can start at any point and then walk around. We'll go down this distance, which they tell us is x plus 5 units. Then we'll walk up 2 units, 8 more, and then 3x units. And then we'll go across x plus 13 units, and then finally 3x plus 2 units, till we get all the way around. So to find this distance around, all we need to do is add up each of these sides. So starting with our x plus 5, we walk x plus 5 units, then we walk 2, then 8, then 3x, then x plus 13, and finally we walk 3x plus 2 units to get to our starting point. Now we need to simplify this. We have a number of x's, so let's group those together, and then we'll group our constants separately. So we have x plus 3x plus x plus 3x. And then our constants are in blue here. We have 5 plus 2 plus 8 plus 13 plus 2. So now we've grouped our x's and our constants. And looking at our x's, you can think about this as adding up apples. We have 1 apple plus 3 apples so that gives us 4. Then we have 1 more, which gives us 5, and then 3 more gives us 8. So we have 8 apples. And remember, our x's have a coefficient of 1, so you can think about adding those coefficients to get to our 8. And then we have our constants. 5 plus 2 gives us 7, plus 8 gets us to 15. And then we have our plus 13 plus 2. So 15 plus 13 gives us 28. And then we add 2, that gives us 30. So all our constants added up equal 30. So we can say that the distance around this figure is 8x plus 30. And looking at our options, that would be option C.